Okay, testing 1, 2, 3. Yes, if I've got, I'll do the screen share. That should get it activated. Yep, I'm good. Okay. Now we're going. I thought I was already in there. Oh, here we go. All right, there may be, I've got one or two folks here, maybe about one at least, and I'm going to go ahead and get started. And those of you who will come in can catch everything on the back end and front end of this. And we're going to take a look today at chapter 13. We're going to do inner joins, and I'm pretty sure that on Tuesday I went over a lot of those resources that are there, and also and talk about what we've got coming up and all that beeswax. And just to make sure, I've got some resources here as usual. I'll try to give you something to take a look at, and a nice application of a database. And these focus really on data warehousing and the some of the applications of that technology. And again, you know, I'm starting a little early, so if people have to get out early, they can do that or bug out. And it's recorded, so you can always take a look at it. And again, we had covered chapters 10 through 12 in the Patrick text, which is the SQL fundamentals. And we're going to take a look at chapter 13, which deals with inner joins. And what we did through 10th, 11, and 12 is we did row and column functions so we could summarize and convert data in rows and then in columns. And now that we have that kind of we have those operations identified, the next step for us is to combine tables. And the very first step in that is to use an inner join. Now, I want to make sure that I alert everybody to this. This is a PDF file, and it may render itself up fast enough to be worth the time. But I want you to go over and take a look at SAS Visual Analytics, which is a software environment that they do about as good as anybody in terms of combining a database with an analytic engine, i.e. a spreadsheet. So you'll want to go over there. I think the Teradata, if I'm not mistaken, I think what is the I'll have to go and take a look for the password. I think it's big data, if I'm not mistaken, but I could be wrong. If you go there and you have trouble getting it in with the password, I'll go there and take a look to see. But I want you to become familiar with it, and so you can see some of the commercial products that are out there. And if I'm not mistaken, there is I believe I have an assignment for you down the road working with SAS Visual Analytics. Now, as I mentioned before, I always try to give you some kind of practical use of these things, and we talked about information builders and some of these trends in data warehousing, and this notion of a data warehouse versus a data mart. A data mart is a part of a data warehouse, and then we can, and so what we have is this concept where we have relevant data. Maybe they're related to a dimension of a company. Maybe they come in from a particular set of operations of a company, and then we go through that warehouse and through those marts, and we snatch the data that we want, we process it, work with it, and so forth. And that's the basic idea behind it. Now, as I'd mentioned, this here is the upload for those chapters and for 10, 11, 12. So use the same one each time. And I'm going to open it up for a minute and download it to the desktop and show all of you what I'm talking about. So we'll open that and then download it, and then we put it on the desktop. and you'll want to save it. And if you didn't do that Tuesday, you should do it now, because you'll have those assignments done. So I can save it, as whatever you want, like LD 10 through 12, whatever you do. It doesn't matter. When you load it in your bin, I know it's yours. And I'm just going to skip that. Well, we'll save the database as, and I'm going to put it as an access, and it's going to ask me to put it somewhere, and I'm going to put it on the desktop so I can work with it. And I'm just going to, this is SQL Fun Chapter 10 through 12 upload. Now, if you have trouble finding this file over in the modules area, okay, you'll find it in the files as well. So just very briefly, and just to kind of walk us through this idea of a data warehouse, you'll notice up here, whether you have a data mart or a data warehouse, you're going to tend to have a whole more tables than you do queries. And as you've noticed, as we've worked through the textbook, okay, they'll give us a beginning table and then an ending table, and typically we'll have far fewer rows in the ending tables than we do in the beginning table, and that's because we're calling through and we're getting information out, we're mining data. Now, when we start to move into joins of tables, we get into what we call a multiplicative effect, where we start to get more than we get a sum that's essentially larger than the whole is greater than the sum of its parts. And it's when we're able to combine tables that we can really get solid pictures of transactions, solid pictures of that can help us build predictive data, etc. It just depends on the detail. But again, you want to have the all access shutter open, and then we've got all the different tables. And as we talked about the difference between dimension tables and fact tables, okay? And in fact, and as you recall, when we started the course, we were working with a data warehouse situation where we had literally the authors had called some of the tables DIM and then the name of the table, and then a fact. We think it was like the fact sales table. So we'll scroll down here, and you'll see now here are the queries, okay, and the different chapters and the workarounds as we went through them. And like I said, what I try to do is to walk you through what I think are going to be the most useful or beneficial queries to work with, in terms of just seeing an example of what you're doing with them, and also the types you're probably going to run into at work. And to remind you that when we're in this graphic user environment where we can see these objects like these tables and queries and all this, this is why people invented object-oriented programming, so that you didn't have to write a program to create all this stuff. Once it's created, the objects are all there, and then you do whatever you're going to do with them. Then we have form, and we talked about that, okay? And then we had the reports, and we talked about that as well. The reports become rather bulky. Now, again, I cannot emphasize enough to you that when you go and look at the SAS Visual Analytics, and you play around with it, you're going to see that it tries to combine a database with a spreadsheet, and that's kind of the holy grail. The closest thing that we have in terms of that is over in Excel. Excuse me, the pivot table. That's the closest one that we have, and there's another commercial product out there. It would be Tableau, and you could certainly go over and take a look at it. Now, we've got this database, and this is the 10 through 12, and what I asked you to upload. We've got some of these queries in it, and as I mentioned before, on some of these, you're going to want to run the query, get the data, and then go take it and dump it into Excel, okay, typically, if you don't have too many cases, or too many dimensions, and then work with the data, doing whatever operations you need to do. It's just trying to write some of the code for the operations here, or converting data to a type that you need becomes it just becomes bulky. And the bottom line is this stuff should help you make a decision not turn you into some kind of a nerd that has to live on access. So that being said, we're going to work with chapter 13, okay, and that we're going to in that chapter we're going to begin to work with inner joins. We've done row functions, we've done column functions, we've messed with date functions, all of these different functions. And if you recall, if you look at the top of Excel, when you open it up, you're going to see all the different types of functions they have there. They're just, you don't have to write code to use them. And so we even had things where we convert stuff to character, to integer. We take text and convert it to integers, all business. We can do the same thing in Excel. Now I'm going to pop over here to chapter 13, and we've done the count. We've used counts and distinct counts and all that business. We worked through that, and we divided the table. We did grouping, and then we're over now to 13, and that's the inner joins. So we're going to do this. Go back over into the files area, okay, and we're going to look for the Patrick files, and that's that zip file that has the Patrick files plus the code that we're going to use for the course. Pardon me, the code we're going to use for today. So we'll come down, it'll be called Patrick Materials. All right, and there it is. There's the zip file, and I'm going to download it. And what I'm going to do is diminish my browser down, and I'm going to throw it on my desktop. And I'll copy and replace it, why not? And we'll throw that down there and copy and replace that. So we're good to go. So I've got the zip code, pardon me, the zip file. Well, I've got the database, okay, and I've got the text files that have the code we're going to work with for each of them. And this is going to be chapter 13. So you'll find chapter 13, open it up, okay, and you're going to see that we're going to encounter some new critters here as well in terms of working with these tables. Now, I want to direct your attention over to page, it would be 474. This is the table of contents for this chapter. And the reason is they're going to walk us through, okay, the join and different join techniques. They walk us through the inner join, and then they're going to talk about the right hand, a left hand join, a right hand join, what that's all about, and then some of the applications for them and what we can do with them. Page 476 shows you, in essence, what happens. You've got 4 tables there of varying size and type, okay, and then you run the join, okay, you run the query, and embedded in that query is a join operation of some type. And notice how you condense those 4 down to a table, okay? And that result table is drawn out of that whole table that's made of those. And so we extract the data out, and that's why we use that term data mining, because we're extracting some data out. Now, he walks you through over on page 478 the various steps to get there, okay? And so this just becomes an issue of you just working through a process. Now, over on 480, he shows us some new, and as I mentioned, we got some new critters. I want to show what we're talking about. If you take a look at here at 13.3, okay, you're going to see select A dot fruit, A dot F underscore number, B dot C underscore number, B dot color from SEC 1303 underscore fruits, A, SEC underscore colors B. Here's what they're doing. As you remember, we use the words as when we wanted to create a column alias to rename a column that would make sense to the user. What we're doing here is we're taking a table and we're creating a pseudo table, okay, and we'll name it up here in the select clause, okay, and then we identify the real table we pull it from. And so we're using this table. Table A up here is actually SEC 13013 underscore fruits, and the other is SEC 1303 underscore colors. This is why this becomes such a powerful thing, because I can do this as long as I I can have as many pseudo tables up here as I want. In others, I can take the same table and replicate it as much as I want. Make copies of it in any number of copies, as long as in the from statement, okay? As long as in the from statement, I identify table A, B, C, etc. Now, what's typical in an inner join is this part right here, where we do the where, okay? And this is where the F underscore number equals B dot C underscore number. And then we're going to order it by fruit. Now, just to kind of take this from some of the abstraction of it back down to a little bit of what's a little more manageable for our brains. If you take a look at 480, okay, you're going to see beginning table 1 and beginning table 2. These are fruits and these are colors. They're dimensions, okay? This could be, I don't know, SUVs and compacts. Whatever two dimensions you could insert them. The authors here are just go ahead and say, I've got this thing called, I've got these different types of fruit. Some of them have the same color, some of them do not, okay? And so we're going to try to find the relationship between them and produce some output. So you'll see beginning table 1 is the fruits table. And as you note here, we took the fruit table, okay, and we duplicated it twice. We did the same thing with the color table, and then we identified the home or what I would call the parent tables, okay. And then I have some kind of a conditional statement, and have the operator in there. That's the equal sign, and then I order it. Okay. This is how I can draw. So I can get a better and better picture, say, of a transaction that consists of multiple elements, or maybe characteristics about a person. Who knows? But I use this process of duplication, okay, of using these pseudo tables is what I would call them. Now, this is really powerful stuff for the simple reason I'm not recreating the tables. I'm invoking code that mimics the table. So when this is all done, all that's left is the tables that I drew them from, they're down there. But the other stuff I created, the code is created. So we're going to select the fruit. Okay, we're going to do this. So we'll copy this, and then we'll go ahead and open up SQL Fun. And we're going to click Create. You said, is it possible I could string thousands of these tables together and do mighty things? Yeah, that's what Google does all of the time. Now, we're going to do query design, click close, SQL, and we'll put that in there. If I copied it right, we'll run our query, and there we are. And what this shows us now, I could, if I wanted to, go ahead and take these columns that are kind of meaningless and give them some relevance by renaming them or whatever I would choose to do. But here I've got, apple is red, banana's yellow, cherry's red. So one of the things we can do is we can work with dimensions that are different but share similar properties. And let me give you an example. Every model of car has what? It has wheels, it has tires, it has an engine, and many vehicles that have will share the same type of they'll share the same type of suspension, but then the frame that gets stuck on the thing, the body is different, and so you have this type of car versus that type of car when they are essentially at the core level the same car, just some tweaking. So what we've done is we've taken these dimensions that are different. Okay, now when you hear people talk, I'll stop for a minute. When you hear people talk about metadata Everybody gets all concerned about that, especially around privacy. This is a good example of what we call metadata, fruit. Okay? If I was the NSA, National Security Agency, and I was concerned about you, okay, unless I get a court order to go directly into your phone number, I can go to the phone company and say, give me all of the calls made from this area code to that area code. And typically it's going to be an area code where, say, certain types of folks hang out or live, whatever, and I'm going to link it to a country or another part of the United States, whatever. And people got all incensed about, well, it's metadata. And if I start and if I see that there's a whole bunch of calls from the 405 call zip area code to wherever, I'm going to court because I want to go and look in those records and see what's going on. In the same way, here you have metadata in the form of fruit and colors. Okay? So when you hear people use those terms, that's what you got. Well, that's 13.3, okay, and we did that, and we'll just call that, we'll go ahead and save that as 13.3. And again, we did an inner join. Now, let's go into the hood on this jewel and take a look for a moment at the design, okay? And we're down now in the design view, and you'll see here are the two tables, the pseudo tables, okay? And then I've got down here in the field, I've got the fruit from table A, and I've got that in ascending order. And then I've got the number, the fruit number from A, and then I've got the color number and the color from B. And here in the criteria, I said where B dot, where B number equals the C number. Now, let's go down into the code, although we've got it right there in front of us, and notice this is where the numbers in each table, table A and table B, are equal. And you say, well, okay, that's great. How could I see that maybe better? Let's click up on database tools for a minute. And let's look at relationships. And there you see all the relationships that all of these tables are tied together. This shows you how they're all aligned. Now, this is useful for a very simple reason. You can, and this is a nice feature and access of all the commercial products out there have these. Although you and I at decision-making levels won't see them, and we might get a report, maybe we won't be able to change them, but we can see the flow of information. Okay, and we can see how things are organized. Now let's look at this for just a moment. And I want to find, go down here to, let's just look at this for a sec, because this is a good example of what we're talking about, okay? Now, we have foods, and you can see how many things feed into foods, okay? Now, we've got departments over here and employees. That's a simple one. And just take your cursor and put it on that one and click Edit Relationship. And it's going to show you the parent on the left side, the child on the right side. And you're going to see the table or query, and then the field that's in the parent and in the child. The parent's always on the left, child on the right. Then you're going to see it's going to ask you some questions. Do you want to enforce referential integrity? Meaning, do we want to make sure everything matches? Yeah. Now, if you look at the bottom here, you'll see a relationship of one to many. And when you think about the logic of it, is it possible for a department to have several employees? Of course. So that's why we have a one-to-many relationship established there. Now, I'm going to click on Join Type, and I'm going to see the three types of joins. Okay? I'm going to see an inner join. Okay? That's where I have basically an intersection between the two tables. And then I'm going to have a left join where I get everything from the parent and whatever matches from the child. And then the third is everything that's in the child and what matches with the parent. So I've got three different strategies and three different data sets I'll get when I run that. It just depends on what I'm after. So we'll close that off. And we've been on down there before, and we've seen what that looks like. But again, this helps you understand what's going on. Let me cancel this for a minute because I want to go back to the database tools. And there is a tool over there. Again, you won't be seeing what you will probably get, especially if you go to work for a large company, will be a guide that will tell you what are in the main entities, like the tables. And I think over here somewhere I have a PDF that has Oracle's guide for retailers. So if you use the Oracle product, they have a complete guide that says here are all the tables that you're going to put your data in, and what will be in those columns or dimensions, etc. That's because they're setting up to train you to run stuff like they want it run, and hopefully you'll get the result set that you want. And the database documenter, we'll click on it for just a sec. It will show you, okay, all that we've got, okay, and we can get the documentation. I'm just going to get on the alphabet table, and I'm going to click OK, and it's going to give me a written report. That's all, using an entity relationship diagram. Okay, that's really all that's going on there. It's just a way for us to design. Now, another thing we can do, and it's helpful for us, is to click on, and we'll click on these database tools, and we'll click on the documenter again. Pardon me, I don't want to do the document. I want to do the analyze the table. Okay, and I can take a look at it and see what's inside of it, etc. Okay, and then I'm going to close this relationship off. All right, and I'm going to click on this. I have this table I just ran. Okay, and what I want to do is click here, and then on object dependencies. And it's going to show the objects that this depends upon. In other words, the downstream stuff, and then the objects that depend on it, the downstream. Objects that depend on me, that's the downstream. Objects that I depend upon, that's the upstream. And you can see the tables the tables that it's drawn from. Okay, now you may or may not have this type of thing, but if you ask yourself, where's the flow here? This will help you. Now, a database, if it's designed well, will show you the flow of data within your organization, and also in the end, it's going to show you. It's really going to show you your key variables, i.e., the dimensions. It's going to show you what are key performance indicators as transactions of one type or the other. And by transaction, I mean stuff that's just cataloged, this is what happened on that date, or transactions in terms of here were the sales, etc. So that's pretty much what's going on there with that. Now, and they talk about the table alias over there, and if you take a look over there on page 43, they show us another one where we're working with a many-to-one relationship. Now, a one-to-one relationship and a one-to-many makes sense to us, but a many-to-one is a little bit different critter. And so let's look at this for just a moment, okay? And this is 13.4. And as we move into some of these more complex queries, what you're going to find is there will be a lot more narrative from me and talking about the text as opposed to just cutting and pasting code. If you understand this, okay, two things are going to happen. One is every time you intersect a document in your company or you intersect one of its database tools, you're going to be thinking about what data are we collecting? Why are we collecting it? Why would that be important? Well, it's going to be important for a very simple reason. That's how you're going to figure out how your business operates, okay? Because what gets counted gets done, and what gets done usually gets counted. So I'm going to select that there, okay? And if you need to, you can have an intelligent conversation with the folks over in IT, or if you're using a vendor. I'll do query design. I'll go back and we'll run the SQL. I'll put that in. You say it really cannot be this simple. Yes, it is this simple. That's this thing that's so sad to me, is that most of this is so simple. And I'm always amazed that we don't have more students in computer science or in accounting, but certainly computer science, because it really is, a moron could do it. How do I know? Because I was a moron for 12 years, and now I'm an honorary moron. And the truth is, let me suggest this. When you get some time, I know you're busy, you're college, you get classes of this, go over to the Code Academy and just play around with some of the languages there, some of the beginning languages, and just see. You may find, I kind of like this. Okay? And there may be something out there. You may say, maybe I should get certified, get some certifications. Maybe I ought to think about a master's program. Who knows? Okay? But the worst thing that can ever happen, and you're going to run into this, so I might as well talk about it now, is you're out at work and you're running a company for somebody, or you're running a major part of their company, and you have to interact with someone who does the technology, and they have no business background, and they have no sense of the context of what you're doing. And if they don't have a sense of the context, it's no good. So what we're doing here for you is we're providing you a sense of context, so you understand, for example, if you're collecting data by hand, critical data, that's like playing Russian roulette today, because if stuff's missing, you don't know if it's a null or a zero, etc. We've talked about all of that. If you're using swipe cards, you want to know where did the data go, who owns it, who gets it, etc. If you're paying 6% fee for transactions, okay, to take people's credit cards, then that changes your pricing structure. But you also need to be asking the vendor, what information are you getting? Okay, what data are you collecting? Because you're paying for it. And all I can say is, if you take any product today, okay, versus 50 years ago, the information embedded in that product is about 3 times what it was. You say, what in the world do you mean? Well, what would be a good example? This computer screen. It was manufactured. It's made of stuff. I can bust it apart. I can melt it down, etc. But think of the information that's buried in here. The design, the physics, all of the science that had to go into create this thing. That's what makes it valuable. And then to design in a way I could make multiples of it. And this is where the world you're in is headed, is where value is hidden. Is the value in almost everything is its informational content. Okay? And I think you've probably heard me say it before. I'm a classic movie buff, and when Turner Classic Movies, their very first movie they ever showed was Gone with the Wind. My grandparents didn't like it because it had cussing in it. You know, at the end, Clark Gable says, "Frankly, my dear," my grandparents thought that was just a awful satanic movie. They lived in a different world than I did. But the number of people who saw that movie on cable that night, more people saw it that night on cable than had seen it in its entire production run. So how valuable is that intellectual property? Well, it's valuable because people they want to see the story, they want to study the film, etc. The reasons people would watch that movie at any given time could be a whole range of things, ranging from a person who's a film critic to somebody who just likes a schmaltzy story, or someone who's interested in the Civil War, whatever. Okay, that being said, we've got this query run, and we've done a many-to-one. And if you look there at the bottom, you're going to see again our friends, that's the bottom of page 43, the pseudo tables. Okay, and this time we ordered them by the fruit, and basically we just did the one-to-many because of that relationship. Now I'm going to go down to the design view, okay, and we're going to see again that linkage between B and C, tables B and C on the number, and then we're going to see what we're getting out of A and B in terms of the field and the table. Now we'll just run it. There's the result set. And we can go down to the SQL view, and there it is. Okay. So we've got a many to one. Now, over on page 45, that's 13.5, they show you another one-to-many relationship. So let's open up the code we've got here. Okay. And again, a one-to-many would be like a mother to child, mother and their children, an actor and the roles they've played, a team and the other teams they've beaten, a baseball pitcher and the games that baseball pitcher won. That's a one-to-many. Okay. Now, if we say who won the most games, now we begin to talk about a little bit different critter. We're doing a one-to-many here, and we're just going to select this 13.5. Okay. And we're going to control, and we'll just go ahead, and we've got the code, and we'll click create. This one right here is going to be, we'll say this first of all is 13.4. And now we're working on 13.5. So we'll click create, query design, in the SQL. And there it is. We have the fruit number, and the color. And again, we're back to that one-to-many relationship, and that's going to be 13.5. Okay? And it would be good for you to stop and think about how might that be. Well, okay, let me show you an example of what I'm talking about. All right, let's go back out to the internet for a minute. Okay, some of you are in here or are at home, wherever you're at, shopping for shoes, you know, whatever you people do. I'll pray for you. And let's see, I'm going to go over to Tulsa. It's a nice motor company. Now I know that Tulsa makes models, and I've got a Model S, a Model 3, and a Model X. Okay? Now Model S is one. Can I get it in different colors? I guess I can. I would assume they let me have different colors. It's a very unique vehicle. Yada, yada, yada. They give us the winter challenge. So I guess I can get, you know, all these different, you know, I can get all these different products or different features. So I've got a one-to-many. You know, get a charging estimator, what it costs. Electric car. Oh, yes. Okay. Now, again, that's a one-to-many situation where I'm working with, and think about it. I'm selling this one model of the car. I can think about it in terms of what different colors do people want. Okay, do they want all-wheel drive or no all-wheel drive? Do they want, what kind of infotainment package do they want? What type of interior do they want? Do they want to have driver memory or not? How do you know what driver memory is? How did I live without it? I get in the car and I press number 1. It's all set up for me. Oh, I gets in, she does 2. It's all set up for her. And the other car, she's 1 and I'm 2. So we keep everything equal. I'm a good husband. I take orders well. Although it's been a struggle, but I take orders well. I think, I know this, I'm doing it well enough. I won't be killed in my sleep, at least this week. So away we go, and we're going to work on 13.6. We'll take a look at it for just a second, and that's going to take us over. 13.6 will take us over to a many-to-many relationship, okay, where we're taking many objects and relating them to many other things. And let's think about this. We've got the fruit, okay, and I've got that code colored there for us. We've got fruit, a number and a color, and then the fruits is table A, the colors are table B, I link them up where the numbers are equal, and then order by fruit. And I'm going to take that, and they'll show us the beginning, and they'll show us the beginning tables, and it should show us the result sets. Okay, and I'm just trying to get that type of relation, many to many, and I'll click create. Go to the SQL, boom. I'll run it, and there's my many to many relationship. For example, they show us fruits. Apples can be red and green. Bananas, yellow. Cherries are red. Grapes can be purple and green. Okay. Orange is orange. Strawberries can be red and green. Had you thought about that, Lisa? You probably hadn't. You see, one of the other things is this is almost like a biology class, isn't it? You hadn't even thought about that lately, had you? Because you had multicolored fruit. Because probably none of you eat fruit. You probably drink all these high things that get you going crazy and all that, what the energy drinks, all that stuff. Okay. I had an energy drink when I was your age. It was my parents screaming at me. But that's a whole, that's for another day. So this is going to be 13.6. And so I'm going to call. Now what I might do is I might say, okay, I've got a model of a car, and I want to find out all the cars that we've made that have all these different characteristics. So I've got, mine has more than one model, and I want to pull those with all the different features in. What would be another mini? Authors to books. That would be one. Okay, so we've done 13, 4, 5, and 6. So we've done these many to many relationships. Now listen. The key thing here that I want you to grasp is that we're working with some simplistic models, but this is a way to think about whatever service product bundle you may offer, or to try to understand it, or you may be asked to pull that together. You know, let's say you work at Applebee's, and the boss comes in and says, "Here are the 6 states. We want you to pull the sales receipts for." What would be something Applebee's offers? It's really, really good. I don't know, but I want to get the sales data on it, and then I want to find out if you've got a sales transaction for that item. How many times when someone bought that item did they buy a dessert? In fact, I'd like it by city. Now I've got now I've got some data that I can do and use for some information. And if you take a look at over on page 488, you're going to see, okay, the beginning table and the 2 beginning tables, and then the results set. Okay, and you'll notice that most of the time when we do this, we will have nearly as many or more records, i.e. rows, than we do in the 2 tables. So we combine those tables and put them together. And we did that just doing an inner join. And the inner join is always this critter right here, where we join them on, usually it's on some kind of number. That's where the inner join. And that's why when we were talking about earlier about designing tables and building tables, that it's important for us to have a unique identifier for every table, for every row. That's how we start to get this effect. Well, and on 13.7, he walks us through a process where we get rid of any unmatched rows, okay? Now, the reason being is this is just an economizing kind of feature. So if I run a query like this and I've got 1,000,000 records, and then I'm going to generate from those 1,000,000 records maybe 800,000 records or 700,000. I want to dump whatever I don't need. And so over in 13.7, that's page 490, they show you that. You have the beginning tables, and then you have a little bit smaller result table because, okay, we've eliminated any of those, we've eliminated those unnecessary records, okay? And the authors give us some verbiage about that over on 489, okay? And we get rid of anything that doesn't have a matching row. So we'll do 13.7, and if we have rows that don't match, and we say bye-bye. And this is just, again, it's an economizing thing, and to just get the information that we want and nothing more. So we'll go ahead and do the query design. And we'll run it. And that's going to be 13.7. Okay? All righty. Now, over on page 491, and this is in 13.8. They begin to help us deal with the thing that can vex us, not convex, but can vex us. Rows with a null, the bane of all of us. Nulls we hate because we don't know what they really are. And that's going to be 13.8. That's at the bottom of the 491. Here it is. Okay, we're going to select the fruit. And we've got the pseudo tables. And then we identify the tables. And here we called, and in this case, we do it where the numbers match up, and then we order by the fruit. Okay, so they've got to match up in terms of the numbers or by the fruit. So click there, and we'll click create, and we'll do the SQL. And each of these, if you want to kind of get a sense, it's always good to go in and kind of take a look at the business problem that they're or the business cases, what you use case. I need to put in. You're right. I'm sorry. Okay, back off. Thank you. All right, I'm going to put in select. I made a mistake there. Get that out, and we'll run it. There we go. All right, now 492. So you can kind of get a feeling of what happens here. If you look at 492, you're going to see the beginning table for fruits and colors. Okay. Then look down at the result table. Okay. Now you're going to notice that some of those unmatched rows or those rows with nulls are gone, and that's going to be the kiwi. Okay, because it's got its number is null, and even though it's brown, it has no number. So we drop it. It just doesn't appear. That's how we get rid of incomplete records. The problem is we've got a kiwi and we know it's brown, and we have to ask ourselves, did somebody forget to input the data? What happened there? And that's why I groused so much about building tables and having some integrity in those tables when we build them, because otherwise we get junk data like that. And what we did there is we just got rid of the rows, which is fine, and everything looks pretty. But now over on page 494, the author, who is obviously paid by the page, gives us 5 different ways to write this query. And he's going to let us see every one of them. And he shows us the best one, the best solution. And he tells us to show the 5 ways of writing the SQL for the inner join used in the previous sections. Well, let's look at each of those. Okay. Now, the first one, that's the best one. And here we start in the select statement. Okay, we're getting our pseudo tables. Then we identify the tables in the from. Okay, then we link them up by number, and we order them by fruit. That's the best solution. Now, here's a second variation on a theme. And I'm going to talk you through this rather than have you write the code, because I think you understand enough about this now you can see it. Select A dot asterisk means get everything out of A. Okay. B dot asterisk means everything out of B. One of the interesting things that makes mathematics such a beautiful language is that it can become so condensed. The reason that poetry is such a beautiful thing is it can be condensed. Okay, you can just condense a whole lot of information. Yeah, and you could take any famous saying out of Shakespeare, And a lot of what he just takes some huge ideas and just boom. We're thinking about E equals mc squared. Energy equals mass times velocity squared. Boom. When we usually the simplest solution is the best, and because all this is underlying mathematics, it's really beautiful. So you can see this: select A dot asterisk, B dot asterisk. Okay, and I had my late uncle, his family, they had a game they'd play, and his wife would say, "Do you still love me?" And he'd say, "Well, I'll tell you when I quit loving you," which was an interesting way to approach it. I thought, okay, you get negatory information, otherwise you accept it as a positive thing. I thought that was an interesting way to deal with that. Okay, now B dot, we're getting everything out of B, and then we identify the tables, and we do the where and the order. Now, here's the third variation. In this one, instead of using A or B, we use a name or a moniker that makes sense, like fruit, like fruit dot F number, call dot C number, call, and of course fruits is fruit, and colors is call or COL. Okay. You say, so you're saying I could name that pseudo table the left hand side of the dot. I could name it to mean something that I like. Yeah. You see, this sounds suspiciously like a website. Yeah. Here, think about this for a minute. okbu.edu. Now that could be Okarche Baptist University, or it could be Oklahoma Baptist University. OBU is who? Our friends in Arkansas who got that domain before us. See, there's even domains out there. OKBU. Okay. Okarche? No. Oklahoma Baptist University. Okay. You learn something new every day, don't you? It's amazing. All right. And then they have the fourth variation. And this is just more extensive, where you use basically the whole table name. And then 5, they say this is fine for computers, confusing for people, not recommended. And it says select fruit. And what they do is they say, okay, select fruit, okay, and then the F number, C underscore number, color from SEC 13, section 1309 fruits, section 1309 colors, where F underscore number equals C underscore number, and then order it by fruit. So you've used an implied name, and it is confusing. So I'd say stick with the best solution or stick with number 2. All righty. So we worked through 13.8. 13.10 is just more of the same, just making it a little more complex, adding in more rows, okay, in the select statement. I'll show you. Let's just come down here and you'll see after all those variations. And here in 13.10, you can see we're just getting more and more rows, and now we have a different little critter here. We'll take a look at here in just a minute. So let's click create. I'll do the query design, and this time we're going to use the and statement. Okay. Now let's talk about this for just a minute, and let me go into the format for that, the font, and bring it up just a hair so we can see it. Okay. We've got a table A, 3 items from it, a table B, 3 items from it, and then we identify what A actually is and what B actually is. Okay. And we have and then here's our familiar where clause. Bit of interesting trivia. Maybe not. I lived only but 40 miles away from Ware, Illinois at one point in my life. What can I say? If only those of you who, and those who are here aren't here today, but here on the broadcast, shame on you. The other people here, for them, will get 50 extra points. I'm just kidding. That's a lie. But it was a dream. I didn't say that. Now, notice I've got all these columns, and then here's where I make it more complex. I use the and, okay? Now, I could use an or, but I'm going to use the and, the Boolean and I'm going to get the join, but I'm joining them together twice to get that. Now let's go back into the code, and there we go. And that's why we use that Boolean and that just makes it a little bit more complex. You'll see the same thing over on, and that's 1310. So we'll save it as that. You're going to see the same thing on 1311. 13-10. I'm going to be getting emails from people. I know. All right. Workable access. We have 498 is 1311. And here's another. And this time we're going to order everything. We're using the between. If you have your, you should have your textbook open, and we're not going to run it, but you can see it. Here's the variation. On 498, when you come down to the where statement, you're going to see that we invoke the between. Okay? Between and. So we're identifying a range. Okay? Before we just got everything. Now we're saying between. Okay? Between the beginning score and the ending score, and then we order it by the student name. So they show the two tables and then the result table, and you're getting a range using the between. That's all that's going on there. Then on page 499, they show you a join using the greater than. You say, this sounds interesting. Do they have one using lesser than? Yeah, they'll probably have one in here for that as well. All the Boolean operations. And you'll see there at the bottom, page 499, 1312 is what that is. That's where the larger number is greater than smaller number. You'll see that in that code, the greater than. In fact, they're going to tell us you can do this less than or equal to, greater than or equal to. It just depends on whatever Boolean operator you use. Okay. Now here's some excitement. Okay. And I know I tell you what, when I was driving over here today to work, I started thinking about this query and I got stoked. I thought, I can't wait. And I went and told Dr. Franklin, I said, I cannot wait till we run 1313 because I'm pumped, I'm ready. And we high-fived. You don't believe me. Well, okay. Now, I'm going to put in the SQL and we're going to run this, Jewel. We'll talk about it real quickly. What I'm doing over here is I'm using this row function. I'm combining the row function with an inner join. So I'm combining the two elements. Just like when you learn a language and you learn some simple phrasing and then you build those phrases and build sentences, etc. Okay? Same thing is going on here. Page 501, I've got the I where, and then I use the operator there is a row function, the plus. And they show us the beginning tables and the ending tables, and this is 1313. Okay. Now, what's going to happen is you're going to be out at work, and you're going to be doing this, but usually what will occur is it won't be written or given to you with the clarity that the textbook does. It'll be kind of a jumbled word problem with your boss mumbling something like saying, oh, and you get this, and you're kind of taking up going, okay. Now, hopefully, you'll also have just some regular queries that you're going to run every week, month, or whatever. Page 502 walks us through inner joins and some variations of them. If you have your text, which you should, page 502, they show you the older syntax and then the newer syntax in Oracle and Access. And look what happens. We're going to select, okay, and then we identify table A. And then we use the inner join condition, that word inner join, and then we use the second. We identify the second table, and then we have on, and that on is, okay, we're going to join these two tables. How are we going to do it? And the on, that line is number A.F number, B.C number, and then we're going to order. So you can see that, and the authors have graciously highlighted that for you so you can see that taking place. So we declare an inner join, and then we say, okay, how are we going to do it? And that's that on phrase that's there. And they show the beginning and the ending tables there, the beginning tables and the result table, and that's 13, 14. And since we're here, we might as well. And let's get the newer syntax, and we'll run it. You say, this is just yeah, okay. The challenge for you is not going to be creating these kinds of things. The challenge for you is going to be trying to understand what your boss or your coworkers or your client or whoever is the end user for this, you being the developer, what they actually want. That's going to be the problem, okay? And that's why data definition is so important. And I can tell you, I just know from experience, this is what when people discover they can you can run queries, or you have that ability to do it, you're gonna have people go query happy on you, and you say, oh, how about this, and you'll get and you might get some information out. Usually what you'll just get is a jumbled mess. Hopefully you'll have some kind of periodic queries that you run so that you know what's going on. And that's why it's important to identify a key performance indicator so you can get that. So we ran that, and I think that's going to be 13, 14, and we'll save it. So you can see pretty much, how this is all pulled together. We've done just about every inner join condition. Now, we're going to look at a new critter, and that's called a lookup table. So let's right-click, and let's close all of these, okay? And you've got all your queries saved. And let's go over to, let's see, find something that's useful. Here we go. Go up to SEC 0815 states and open that table, the states table, okay? Now, this is a simple little table that has the state code, the state name, and the state capital, okay? And I would assume it's probably fed into something else with an address or something of that nature. But, there are 50 states and 50 state codes and 50 state capitals. And so you will want to have something like a drop-down menu that you can use, okay? And I'm going to click on Design, okay? And we're going to do this in the graphic user interface, okay? And I've got this state code, and let's see, all right. I'm going to start with the state code, and I'm going to click, well, wait a minute, I need to create, we'll make this simpler. Click Create, and then create, and then click Table Design, and we've got, we're going to call the state code, and state name. And what was the other? Was it? I think it was the state capital, if I'm not mistaken. Now I'm going to populate. Now I've got these, and the state code, I'm going to go ahead and make that a primary key. I can do it by clicking up here or down here. Okay, and I have my state code. Now I'm going to go, and now I'm ready. I've got the state code, the state name, and the state capital. So I'm going to go into the data sheet view. Let's see, I want to save the table. Yep, I do. And I'm going to call this states. All right, that's a very original name. Now I'm going to put a state code in here. And of course, I can't resist. It's got to be Oklahoma. And the state name. How many of you want to do Massachusetts? Can anybody spell Massachusetts? Probably not. So let's stick with Oklahoma. Okay. You know the song? Okay. You know what? In prior classes, when I had students who were really great students, we'd sing Oklahoma while we did this. But we won't do it today. We'll skip it. Because I think some of you probably have questionable voices. I know I do. I'm kidding. I'm just kidding you. Just kidding. And we got, okay, the state name. And I misspelled the right state of Oklahoma. Look at that. We could have done Alabama and then in honor of Forrest Gump, but we're doing Oklahoma. Oh, well. Which is what I should have done is Alabama in the honor of Forrest Gump. And let's okay. Alabama's AL, and just in his honor. And they anybody know the capital of well, there's me out there, and then there'll be some people probably partying later on. You know what you talking about now? Who knows? And I believe, if I'm not mistaken, the capital is it? I think it's Birmingham or Mobile. Maybe it's Birmingham. I think it's Birmingham. Of Alabama, is it Mobile? Right. Oh, what's the capital? Birmingham. Birmingham. Okay, there we go. All I know is I continued to run, and soon I had left the great state of Alabama. All right, we got the states there, and we're going to close that off. We'll save the table. And now we're ready to go back up here, and now we look at this SEC states table, and we're going to open it up in design view. Did I go too fast?
No, it's actually Montgomery.
Okay. Oh, is it Montgomery? All right. Well, let's find the states table. All right. Let's go down and find it. It's Montgomery. Shame on me. Well, Montgomery. I would have never thought that. I thought it's Montgomery. You're right. I should have remembered from 3rd grade. Let's open this up. And is Montgomery. All righty. Alabama and Oklahoma. All right. Now we'll close that off. And we're good to go. And we've got the states code. And I want to go ahead and I'll go back up here to this. So I'll get the states, open it back up. Okay. And let me see here. I want to go back up here. I'll close this off for just a second. And we're going to come up. And we were looking on that SEC. We had that little other states table. And it was this, I should have written it down because there's so many of these in here. Second states. Events, types, colors. Wow, they got it all going on here. Maybe it's 08 states or something like that. Okay, we're zeroing in here. 0818. All righty. 0818. So 0817. You are my hero. Now, we're going back down here to design view. And on the state code, we've got the general properties field, and we're going to click lookup. And then we're going to click and combo box. And it says a row source type, it's a query. And then we'll come down here to the third, and it says row source, and you'll see a little infinity button, little 3 dots. Okay, now we're going to go find the states table. There it is. And we'll click add, and we'll close. And then we're going to get the state code, the state name, and the state capital. And we're going to run that. Okay, and we've done the query builder, and we're good with that. So we'll close the query builder off. Yep, we're good there. And now What will happen is when we've done that, we'll get the query, we'll get the SQL for that lookup query that we just ran. Now we've done that. Now we need to display it. So we have one bound column, okay, and we have a column count of 3, and the column widths will be, and we're going to put 2 inches, comma, 2 inches. No, pardon me, I messed this up. It's not commas. It's going to be 2 inches, semicolon, 2 inches, semicolon, and then 2 inches. And those 16 on hand, we'll go and let's go up to the data sheet view, and it'll ask us to save us. We'll say save it, or it should be good. We're good. Now, you'll notice the drop-down menu. Okay, you run into these all the time. This is to enforce data integrity and to make sure that when you run these joins, you're doing some nice work. Again, this is an inner join basically, but we've used it for a lookup. And so if I'm down here for this next record, there's Alabama, okay? And now I want to go back in and make sure I show all 3 of them. So let's go back down into the design view on this. I think I messed this up by saying the bound column of 1 column count is 3, 2 inches, 2 inches, 2 inches, column headers, list the rows. Let's go back in and put on the bound column. Let's try 3. And then we'll go back up to the data sheet view and see if that's going to work. Okay, and we got Alabama. Just want to accept this amount. Oh. What? Yep, let's go back down. I don't do it this often, so I'm putting us through this awful experience. And it's not going to let me go back down to design view because I'm editing. So let's go down to design view. Now, insert pronouns data. All right. Let's try that. And all events, let's just kill it and not save. And let's go back down and let's look at that states table and see what we did to it. So I think I got us sidetracked. Okay, let's go down into the lookup. Control, I got a combo box table query. Bound column is 3. Let's leave bound column 1. And we got, I may have put 2 feet in there instead of 2 inches. I'll try it. And you could go ahead and we've done, and this is what happens to me. I do too much working with code and not enough to, let's say it'd be 2 inches. And then the semicolon, then 2 inches, and then the semicolon, and then the 2 inches. And let's save that. And we'll go up to the data sheet view. Okay, let's look at this, and we got Washington. Okay, now here we go. That's what we did. All right, if we click on the code, we'll get Oklahoma, we'll get Alabama, and we're going to get, we can't change the field. Well, I'll go play it at home and play with the thing, but let's just close it off. That's my fault for not having my brain tied into the rest of my neurological system today. Okay, and basically what we did there is we just created a table, a lookup table using the states table that we created. And I'll go back into the GUI later and then post it or something. But they show you some of those applications of joins, summarization. It gives often an Oracle tangent. And that pretty much does chapter 13. So let's take this and we'll go ahead and we'll save this file, okay? And you save it, and you should have it down there. Save the database as, access database, save as, and have it on your desktop. And I will play around with that lookup table. I just haven't messed with one. I'm going to have to start doing that some more. Click save. Yeah, we'll replace it. And then you've got the 10 through, the one we did the other day that's over there in the files, okay? And let me get us back over here, okay? It's got that, I'll go over to the modules area. That one, we talked about that. Here it is. You'll want to upload this for Lunch's database 10, 11, and 12, and then what we did today, upload it for 13. Okay, folks? Thank you so much. Sorry about the little bit of a snag at the end. I'll try to get my brain wired in to work on that and do it. And then next week or something, we'll go back and do it successfully. We'll use another one. All right. Thank you very much. And I'm going to stop the share, and then I'll stop the